right, so y'all, we're moving on. It's I forgot what we were like in chapter 12. Now we're in chapter 9. I think we do chapter 11 next. I think matrices is always the best way to start the year off because it's not. Well, because it wasn't just a terrible start, right? It was. I don't know. Now, we're going to look at sequences and series. This starts off a little bit like geometry. There was like a little bit of a chapter in geometry with sequences and series, like we spent 2 days on it. We're going to start with that, and then it gets to stuff that looks like similar to calculus. It's summations. It's like got a big Greek letter, sigma. Anyway, that's what... Oh, boy. Okay. So anyway, we're going to have, at first the formulas are just kind of weird. It's just something you're going to have to accept. You, I think, learned this before. I did have one geometry class where we didn't spend time. I don't know what geometry class it was. We didn't spend much time on it at all. So probably y'all's. So anyway, we learned, if you did learn it, we learned something called a recursive formula and an explicit formula. Do y'all remember that? No, recursive and explicit. Okay. Recursive formula is kind of weird because it's just finding, I don't know, it just kind of explains what's going on in the sequence. An explicit formula is a formula that you can create to find, say, the 100th term of something. Like if you have something going on and do you want to count out to 100 terms? No. So you can create a formula and plug it in and get to the end of it. Yeah, so that's what an explicit formula is. Anyway, that's what we're going to learn. But a sequence, y'all listening, it's just a list of numbers, okay? A term, you just select one of them, okay? That's your term in your sequence. All right? We'll eventually get to something called a series. A series is when we add them up. But is anybody writing any of that or not really? Not really. If you are, I mean, I don't know that you need that. The explicit formula, we'll get to this in just a second.
That's okay.
Y'all don't need it?
No,
I mean, I don't think you need those. This is what we'll need. Okay.
I think it's this there, like this.
Are y'all cold still?
Yes, we're cold.
We're freezing?
No, it's cold.
Okay, I'll turn it off for a second. Okay. All right, so the explicit formula describes the nth term. So if I was looking for the 100th term, then I could plug in the number 100 and find out what it is. That's all that means for the explicit formula. So they're telling me right here, we've got this sequence. It's a list of numbers. I don't have it, but I have the formula for it. So I can find the first 10 terms. How do I find each number? How would I find the first term? I would plug in 1. That would tell me my first term. How would I find the second term? Plug in 2, and so on. So if I made my list of numbers, so let's plug in, I'll just write them as a table. I don't know if they do this, but I will so I can show you. So we have to find 10 numbers, all right? So the first one I would plug in 3 times 1 minus 2. Okay, that they call a sub n. That's just, I'm trying to find my term, my first term. Okay, so what's 3 times 1 minus 2? 1. There's my first term, 1. All right, now let's find the second term. And I would just plug all that in. 3 times 2 minus 2. I put that in my calculator. And it would tell me it's 4. Okay, my third term, 3 times 3 minus 2. 7. Okay, 3 times 4 minus 2. Okay, sorry, I don't know what I was thinking. Okay, do we know what's going on here?
Add 3.
So if you wanted to, how could you finish? Could you keep plugging them in? Yes. Or I can tell I'm adding 3 each time. So you could just finish it out a little bit quicker, right? Add 3. Wait, I was talking the wrong thing. 25, 28. Does that look right? I did that pretty quick. So, or you could keep plugging them in. Does everybody get this?
Can I write that?
Yes.
What does the formula say?
That says, it says a sub n. It's just how they write that. You're trying to find whatever term, the nth term. Okay? And it's 3n minus 2. whatever term you're looking for, oops, you just plug it in. Sorry. And I'll give y'all a second to write that down. I'll see what my next one. Oh, it is recursive formula. It did.
I already texted it. I texted like for that family group thing that
Is anybody still writing? You are? Okay.
I'm sorry, I feel so bad. Just skip it.
I'm missing Logan and Bryson. Am I missing somebody else?
Bryson and Mary Kay.
Okay, yeah, I knew Mary Claire because that's who I'm recording for. Okay, I'm missing a lot. Okay, you're done? Okay. All right, the next one. Let's see. Let me erase. And y'all, they just listed it. I'll show you how they listed all their. They just listed them in order.
Oh, that sounds right.
What? No, I mean, I would take that. That's all your numbers. It's the first 10 numbers. So see, what, y'all are hot? Okay. Yeah. So we're making sure they feel at home watching this from home because if we don't fuss about the air in here, then it's not really our class. Okay.
Our class, the only class that
That back and forth. Yeah, usually everybody's cold. I don't know. Today everybody's been cold. I didn't know it was on turbo. So anyway, this is how they list all theirs. Do what? Yeah, it was just on full blast, but I would just turn it off. But no. If you listed yours like this, that's fine. I see all I needed was the first 10 numbers. How you list them doesn't matter. There they are. Okay, what?
Why is it like that?
Why is it like what? I did the same thing. I did the
Equal
table.
signs right there.
I did the same thing with the little table. They just wrote more. They wrote it different, all in one table.
I didn't know what it was. A times N.
That A sub N. Wait, we were on the.
That's A sub N equals.
Okay, now this was just their formula this time, right? So that next time they can give me a totally different sequence.
So they'll give you a formula each time.
Yeah, now sometimes, I can't really remember, it's been a while, but sometimes we have to figure out a formula or different things. So yeah, this was just our first type of problem.
So
They
maybe
give you a
the-
formula and say, hey, what are the terms of this sequence? So I don't know if y'all need me to do it again, but this one, what is this one asking? It's not asking for the first 10 terms. It says, okay, this is your formula, an explicit formula. What does that say? 12th term. It's A sub 12. Yeah. And what are you doing? You're going to plug in 12. That's all they want. So see, it's written like a foreign language, right? I mean, if you were to read this on the ACT, you might not have a clue what in the world they're saying. Or you might. All they want you to do on this one, they don't need 10 terms. They just want you to plug in 12 times 12 plus 3. See where they put 12 for n? So what are you going to put for n? 12. So what is that? 144 plus 3? It's 147 would be your answer. So that's our first type of problem today. Either one of those. We may find several terms. We may find one specific term.
So how do you write it? Would you put like A sub 12 equals
147. That's probably how they would write it. Let me see if they have. That's just.
What are you doing, Harper?
Okay, that's your first 3 terms. All right, we done? We good? Okay. Now we move on to recursive.
I get weird on this part.
Yeah, I
Hands
handed
get
it for
runny.
these times.
I love it.
Right.
Okay.
All right. Next one is a recursive formula. Let me see. Oh, go back. This one right there.
You don't have to like line back up or anything.
Okay. You got it? You're good?
Can you leave it there?
Yes, I can leave it. I had it better. There you go. I think you can see it. It says 147.
That's okay. I know all over the world is this.
I'll pause it. All right, this is a recursive formula. This one's kind of weird. What? All right, this one is kind of weird. It goes off of your previous term. So you have to have a previous term. It doesn't help you find something that's way later in a sequence, all right? So if you'll notice this a sub 1, the 1 means the first term. That means I'm starting with what number in my sequence. In this example, I'm starting with 133. That's my first term, okay? So in a recursive formula, you're always going to have to state what's the first term. Does everybody understand that? Like, where are you starting? Are you starting at 0? Are you starting at -2? Are you starting at 103? Like, you have to state where your starting number is. From there, okay, is everybody good? That's the first part? And you just say a sub 1. My first term is this. Okay. The next thing, it starts off, you'll write exactly this right here. You're saying, okay, our term, you take the previous term. I know that's confusing. When you subtract 1 from something, you step back 1. Does that make sense? Like, so if instead of the second term, I would start with the first term, the previous term. That's all that means. So you're going to take the previous term and subtract 3 from it. Okay? Kind of? No? Maybe
So
not?
N minus 1
So
just means the previous
that
term.
just means the previous term. So I start with 133.
So that's
To find my next term, I take that term and subtract 3. What's my next one? 130. To find the next term,
Subtract that.
I take my previous
It
term
would be 127.
and subtract 3. What did you say, Chloe?
I said you wouldn't minus 1 from that 133.
No, because that doesn't mean subtract 1. That means take your previous term. Because this is talking about what term are you using, the previous one. It's just seeing what you, it's weird. Recursive formula to me is weird. I don't know the point. There's a point. We gotta learn. Anyway, so that's how you would do that sequence. But every time, what I underlined in blue, it looks like that. You do something with the term before it. Recursive formula, you have to know the term before it to see what the next term is. Explicit formula, you can just plug in whatever number you want and find that term. Okay?
Why is
Oh, look, I didn't know they had the answer up there. What? Why is what? Okay, are we ready for our next example? I mean, it's on this. I haven't done an example like this yet. Anybody ready? We're not ready? Okay. You're so lost? Well, let me do it.
How about you? No, not that.
Oh.
Let's talk about something else.
Okay. So this one, it says, all right, they want us to write a recursive formula. So, and it's got, let's look at our numbers. We've got 1, then what's our next number? 3. What's our next number? Okay, that's kind of correct, I know, but I'll do that. Okay, so let me just write this. 1, 3, 6,
10.
10.
4, 7, 8, 9, 10.
Oh,
Okay,
that's
that's 15. And then that's 15. I'm just trusting you. Okay.
So,
So we take our first term and then so anyway, what is our first term? We always have to say what our first term is. 1. So our first term is 1. Is everybody good with that? You always have to state in the recursive formula. That's what I'm trying to find. Or write as our recursive formula. And I got 1, 3, 6, 10, 15. Oh, there was another one. It was 21. I don't think we can see it. Anyway, it's fine. We've got enough. Is everybody okay with this? Now the hard part. We have to figure out
you have to make
a formula for it. Okay? So it always starts off with, remember I told you this, it always starts off with our term. I mean, our previous term. That's supposed to say, let me try and write that a little bit better. A sub n minus 1. We take our previous term and we do something to that previous term. Now we have to figure out what it is. Like, are we adding 3? Are we, like, what's going on? But not every time, right? Sometimes you multiply and subtract. So, like, I could multiply by 4, subtract 1. multiply by 4, that doesn't work. Could multiply by 2 and add 1. Well, anyway, does anybody see anything
It's
yet?
not right.
No, that's not right. I'm just making up stuff. right
Multiply 2 and add 1's not right.
No, multiply by 2, because then if I multiply by 2 there, that should be 12. That's not working. Multiply by
4 is subtract 2.
3 and multiply by
4
4.
is subtract 2.
If I multiply 3 by 4, that's 12.
Or
Subtract 2
plus
is
1.
10. Yeah, so you've got to figure it out. It looks like this one's kind of tough. On this one, it looks like we are,
Yeah, that's the only thing I can see. You add 2, you add 3, you add 4.
so you add,
Oh,
okay.
In,
I don't have
This
it like
one's
that.
tough. This one's really tough.
it's like in, oh.
So you take your previous term and you're adding, like on this one I'm adding 2, my next term. On this one I'm adding what? 3, my next term. 4. So it's plus n. So that one was crazy.
Okay.
That one was really tough.
Oh.
Normally I do like the way I was saying, like, okay, try multiplying by 2, add 1. Or multiply by 2 and subtract 1. I was trying to do that. So, I know, that's how I always start these off. This one was really weird, where we add in. That's like very
I
abstract.
mean, add in.
Add in. So they said I was like, this is my first term. To get to my next term, term 2, I add 2.
Okay.
To get to term 3,
I thought in meant like the
I add
numbers.
3. This is crazy. I add 4. I would never do that to you on a test. Okay?
You would.
No, I would not. I would not. I do try to keep these simple. Recursive formulas.
Yeah, I got that one right.
This is like
You work it out.
some crazy reasoning. Let's try another one. Okay? On this one, let me see how they. Okay. It says write a recursive definition. It's basically your formula. Okay, look at patterns. So let's just do A. Can y'all see A? The first thing I have to do is write my first term. We're going to look at letter A right now. So my first term is 1. Now, my formula, every time, I'm going to start with my previous term. Okay, now we have to see multiply by 2, multiply by 3, multiply by 4, multiply by 5, multiply by 6. So I wonder if
So it's times
times
in.
n. That's what it looks like. Yeah, it looks like it's times n. I wonder if that's what they're put. Yeah, it's times n. I don't remember doing these like this last year. Because to me, these are
I
hard.
did teach it.
Times n. You just times n. But y'all got it? The next one. Let's look at B. What's our first term on B?
Add 3.
Our first term is 1. And then we take our previous term. And let's see. Multiply by 2.
It's 5 times 6. Oh,
Multiply
I'm sorry,
by
right?
2.
Plus 4.
Um,
14 plus.
How do you get from this term to this term each time?
You add 4.
It says look for simple addition or multiplication patterns.
Times 5. Oh. Times 2, add 4. Times 2,
Times 2.
Yes, I'm trying hard. Add 4. Add 12. Why did she
I don't remember them being. Oh, this one's crazy.
Add n squared.
Yeah. Goodness. Yeah.
What is it?
That's
N
it.
squared.
You add n squared. I would not do these to y'all. You add n squared. It's meaning if okay, what is this one is 2, like that one would be 2 squared. That's my third term. That's my fourth term. That's my 5th term. Am I doing that right? So I would do 1 plus 4.
It's 5.
5 plus 9. 14 plus 16. Anyway, I don't know that I would work right. You were adding in squared. And I love how it says, look for simple addition or multiplication.
I completely guessed.
Yeah,
I got advanced math.
Yeah, that is a bit. I don't even
I
remember.
said add 4,
doing
add 12,
these.
which is taking.
Let me see one on your paper and see what
I
the
think
square
that's
like.
what got it. It's because like it was going up and it was like
Drastically.
it was like
Times
squares.
squares,
Yeah.
But it's like,
Yeah, like,
that would be
everyone's
like a good
hard.
bonus question or something.
You do ask me for a bonus?
Huh?
Yes, Shirley.
I mean, like on your test, I wouldn't put something like that on there. I'm telling you, I don't even remember this. It has been a year though. Okay, no, it's not. It's not going to be terrible. Let's see what's like on your paper. Let me just do one off your paper so you're not scared. Okay, what's a recursive formula? And then find the next term. Look, it's multiple choice. Yay! Okay, so they're saying, and look, it's what's our first term? Our first term is 7. So look, that's right here. Our first term is 7. That says our first term is
Plus
37.
6.
Our first term is 7. Is our first term 6? No, you've already narrowed it down. Okay, and what are you doing to get to each term? Adding 6. So you take your previous term and you add 6. So does everybody understand? See how much better it is on the paper? It was very challenging. Notice every time that's written the same. You're doing something to that previous term.
So the first part, what did you cross out?
Oh, because this right here, it's saying your first term is, what's our first term? 7. Oops, they said on B and D that they were 37 and 6. That's not right. So I can already tell it's not B and it's not D. Okay? So, let's see. I don't even know what time it is. I need to kind of watch the time. Okay, we've got time. All right. So, let me see what we've got next to prepare you for. I've helped y'all through 6. Okay, 6 might be difficult. I don't know. Maybe not. We'll see. Okay. Now let's do an explicit formula. Or do y'all want to do these first? Do y'all want to do these 6? And then I'll teach you the explicit formula. Okay. Please tell me that I remembered to, yeah. Once I want to look at number 24. It's talking about, all right, y'all wait. Okay, let me teach this and then y'all can talk. Okay, so number 24, that one, this is going to be explicit. You have, I think, a few explicit on yours. So it's not using the first term. The best thing you can do on these, let me cover up some so I have room to write up there. Okay, is make a table. What's my first term? 4. Okay, so this is how I always do when I'm dealing with explicit. Because you're trying to say, how do I go from here to here? What's my second term? 5. What's my third term?
6.
My fourth term, 7, and my fifth term is 8. What am I doing to go from my X to my Y, basically? Adding 3. That's your formula. So you would say, okay, my formula is n plus 3. Okay? I believe that's how they write it. Yeah. So they're different. They're totally different. They don't use, that's good. It's not done the same way. It doesn't use the previous term. You have to kind of make a table. Okay? Does everybody kind of understand these? No? Explicit and recursive are 2 totally different formulas. Okay? So, and I think, and this is backwards. To me, the hardest part of the chapter, normally the easiest part of the chapter is the first lesson. To me, the hardest part of this chapter is today's lesson. So I think it gets easier. All right.
Why are we doing physics in here?
Okay, so are y'all on the ball, the one that's, is that what it's bouncing, a ball?
Yeah.
Okay. What number is that?
Number 9.
Number 9. So this is physics. So it starts off at 9. Does everybody understand why I put 0 first?
Yeah, because you have it in your hand.
Because it has not even bounced yet. So my starting point, I haven't done anything. I'm holding this ball. Then it bounces 1 time. Okay? And it comes back 75% of that first number. What is 75% of 9?
0.75.
0.75 times 9. Okay, somebody tell me what that is.
It's 6.75.
It's 6.75. Now, that is bounce 1. So guess what I have to do? Now it came up this high, let's say. So then it bounces again, and I have to take, what was it, 75? 0.75 of that number.
5.06.
So we get 5.06, which some of us thought, oh, that's the third time. No, that's not. It didn't bounce 3 times. It's only bounced twice. So then we bounce the third time,
It should be 30.8.
and every time I'm just multiplying by, this is your number 9.
Is that a 7 right there, 6 points?
75, yeah. 5.06.
Dude, why can't physics be this easy?
It's,
Okay, so the third thing.
I don't know, I'm not good at physics. This
Well,
is-
obviously you're better than him.
You're better.
I understood that.
Way more than, yeah.
It's me every time.
Okay, so, anyway, so we understand that, to me, I think if there's a problem on your test, it's more like this one. Okay, so I kind of pick and choose the easier ones on these.
Yes.
Okay. So anyway, finish that one, you kind of started. Hold on. Oh, wait, I said we're skipping 8. 8 is crazy ridiculous. We never do that one. I haven't looked. Hold on. Oh, probably. Let me see that one. 11's got answer choices. No, I skipped number 10, but somebody said something about number 11. Number 11. Yo, what are you doing to get from 1 to 20, 2 to 40, 3 to 60, 4 to 80? You're not. There you go. So you're looking for the answer where you're multiplying the hours in, I don't know why it's called in, times 20.
I just found it definitely times 10.
So see, these aren't so bad. The ones on the paper aren't near as bad as some. Okay, let me look at number 10. Hold on, let me pause this one.
I got +7.
Yeah.
Okay, keep your paper for today, and then we'll do number 10 hopefully tomorrow.
This is the second time we skipped church for golf.